The next thing that I want to talk about are the hooks within sys. This is in reference to Python's syntax system module, or sys, and there are still even more things that we can do. We've discussed some of the areas pertaining parsing and then pertaining compilation, which are the processes that take your source code into an abstract syntax tree and take your abstract syntax tree into bytecode. But is there anywhere else that I can possibly hook into Python? That I can do things dynamically at runtime even, maybe during this interpretation step. And for those who are unfamiliar with how Python runs things, it starts with human readable source code, translates that into an abstract syntax tree, and then compiles that into bytecode. The bytecode is what you'll see if you ever open up one of those .pyc files that are generated when you do things like imports. That's your bytecode. And then all Python does is it starts running an interpreter, and this interpreter, all it has to do is consume bytecode that is fed to it, and then spit out what's called machine code, which are actual instructions for your specific CPU, specific operating system, things like that. And so there are actually things that we can do live during Python's runtime at this interpretation step. The very first thing that we can do is actually one of the most recent additions to Python's sys module is the audit hook. This lets us arbitrarily perform actions whenever Python encounters a specific dynamic runtime. And so all this means is I want to run this function f every single time Python emits a specific event. And Python starts emitting events all the time. There's a huge table of events that you can parse or that you can use. And in this case, I just want to catch the specific events where Python compiles something or where it executes some code. And you can see whenever I execute this code cell that I'm actually printing the source of my event, or the source that's provided to the compile event, as well as the file name that it comes from. And so this is being run, the code that's being executed is x equals 1, and the name of the function, or the name of the file that's being run from is string. This is what I passed in right to the compile. And I can even execute this specific code, so I can execute x equals 1. And you see here I get another print now, and this corresponds to the execute. But Python doesn't, we don't ever really write compile, we don't write exec, we don't make use of these built-ins very often. So you might be wondering, well, what's the point of this? Well, Python makes extensive use of compilation and execution, as we talked about. And so whenever I'm importing something, I'm actually doing both of these steps. And you see, just by running one import, I'm emitting a very large amount of events. I'm emitting many compiles and many exec statements or functions. And so you can see here that I can hook into Python's runtime and I can do things. I could log and I could say, hey, we're compiling this module, or hey, we're executing this module specifically. And so that's really what hooking into Python sys audit hook is, but there's more interesting parts of sys. We can hook into the import system. So whenever Python specifically imports something, I can have it run some arbitrary function. And what we can do here is actually quite fun. We can essentially compose a graph. And so I'm just going to give you the nitty-gritty, the quick details of this. I'm instantiating this object that I call a finder. It doesn't inherit from anything, so it's really not that fancy. All Python needs is that it has a find spec method. And in this find spec method, I'm going to intercept what module I'm loading and where it came from. And if it's part of a package, or if it's not part of a package, I'm going to say this is a top-level node. And if it is part of a package, I'm going to add an edge between the top-level package and itself. I'm going to instantiate this as a context manager. And I take advantage of this sys meta path. This is what Python searches through when it needs to figure out how to find your imports, hence the meta part. And so just by inserting this, Python will execute this method here every time it tries to find something. tries to find an import, I should say. And so I can use my context manager like this. I can import some things, and then I'm going to use just a little bit of code down here to plot this out for you in matplotlib. And so what we end up with is a very interesting graph of, or a very interesting diagram of all of the packages that are involved in importing email and then importing a sub package from it or sub modules from it. And we can see that they all point back towards the top level package, and we also see that email imports calendar, base64, binASCII, socket, etc. Python gives us many escape hatches, many places that we can hook into it. And let's go ahead and let's test this out with pandas. How many different packages does pandas load when we just import it? And if you've ever imported pandas for your very first time ever on a new machine or a fresh install of Python, you'll know that this takes a minute to do, or maybe not a minute. But we can see there's so many different sub packages that exist within pandas. And let's just grab one of these and zoom in on them. We can see that this is importing pandas_libs, and as part of importing pandas_libs, it has all of these different modules that it has to load in order for pandas to work. And we see pandas does so much importing. I mean, it is a very, very large package, so this is kind of what we should expect. But something else that's equally interesting, we don't just hook into module imports, but we can also hook into function calls. And so what we can do with this is we can pose a different graph. We can take a very, very similar approach, except instead of every time Python tries to import something, we can say every time you run a function, I want you to start building this graph structure for me. And I can represent it in a very similar manner. And so let's just start with some dummy functions here. I define a function f, this function calls g. Define a function g, this function calls h and k. H and k just do nothing, they need to exist. And then I set up my call graph and I call f. And we can see that by performing this call graph, I import from using 2 files and 5 functions. Now the first file is this context manager, so that kind of doesn't count. That's the current file that we're working with. And so you see here that from my context manager, I call f. From f, I call g, and from g, I call h and k. Very simple, very straightforward. But let's take a look at what this might look like for something like matplotlib. Right, and I'm going to have to close out this new figure that I made. And so we'll set up our call graph, and we'll instantiate just a figure, right, the highest level object from matplotlib. And we can see that our call graph is much, much larger. I would really hate to see what this looks like for pandas. But what you can see here is that this call graph has many different features, many different items attached to it, or attributes attached to it, that it dynamically loads for us. And the reason that I say dynamically loads is if we take a look over at what's going on in these nodes, get running interactive framework, get backend module name, load unlocked, new modules, module from spec, create module. To me, this says that it's doing a lot of dynamic importing, and we can actually see if it is. Try one trick here, and that's we'll instantiate one figure before we start our call graph, before we start tracking all those function calls, and then we'll just track the function call or the function calls through a second figure. And we end up with a much simpler graph. And we can see, we can reason about matplotlib is that the first time it performs instantiating any of its high-level objects is that it will dynamically perform a lot of importing, a lot of module loading according to the current state of your system, the current backend that you have selected. Maybe you haven't set that, so it needs to choose that. And so we can see that when I instantiate the second figure, we actually have to do much less code, much less churn. And the last thing, just because we want to, let's take a look at some pandas. And so when we instantiate a data frame, we can actually see it's quite straightforward, right? I instantiate a data frame, I pass it a list of lists, and it's just 5 files and 13 functions. Now what if I feed the data frame constructor a dictionary? Well, instead of 5 files, it's now 16 files and 45 functions. That's a lot of complexity added on just from changing the style that we're instantiating a data frame. Now let's try reading a CSV. What does this look like? This is now 39 files, 136 functions, And I don't even know if this will load. It does load. And so we see here, this is the call graph of just calling read CSV. And in here, we would expect somewhere to instantiate the data frame, but we can hook into Python's vocabulary, Python's runtime, by using this sys module, and we can dynamically do things that are meaningful and that tell us a little bit more about how Python works. And that is some of the power that you get from the sys module.